From this expression, we can derive many two important principles for the fluid in the equilibrium. One is called the Pascal principle. Another is famous Archimedes principle about buoyancy. Okay, and we're not going to see how we can derive it. You can think about by yourself. Let's look at the conclusion. It says that for the Pascal principle, a change in the pressure applied to an enclosed, incompressible fluid. Okay. What's the difference between the compressible and incompressible fluid? Water, liquid, is usually incompressible, and gas is compressible. Okay. So for the fluid, gas and liquid are actually different. They are different with each other by the fact that one can be compressed, another cannot. Okay. So basically it means most of the liquid. So in an enclosed, incompressible fluid is transmitted unchanged to every point of the fluid and to the walls of the container. So the pressure can be changed with, can be transmitted with the same value. Now let's look at the application. Okay. If you look at, this is called the hydraulic press. It's used to lift a very heavy object with a small force. Okay. So we can produce a large force by a small force. You can think about it. It's like this. Here we have a small cross-sectional area A1. Here we have a large cross-sectional area A2. If we apply a small force F1 here, we can produce a large force F2 here. So with if this is much larger than this one, okay, if you enclose some fluid here, you can even push up the car above, okay, upward by one hand. Okay, this is possible. And the reason you can see is that due to the Pascal principle, the pressure at the left hand side, P1, should equal to the pressure at the right hand side, P2. Right? And P1, the pressure equals to force 1 divided by A1. And P2 equals to force 2 divided by cross-section of A2. So to satisfy this equation, you can see if A2 is much greater than A1, then F2 has to be much greater than A1. Okay. So if A2 is 100 times A1, then F2 has to be 100 times A1. So if to produce a large force, you simply need to increase the area for A2 or decrease the area for A1. So by pressure transmitting, you can produce a large force, A1, A2. Okay. Any question here? This is how can we apply the Pascal principle? Okay. And it's interesting to compare the solid and liquid. This is what happens to the liquid. Okay. For solid, it's opposite to that. In liquid, pressure change will be transmitted undiminished. In solid, it's not the pressure, it's the force can be transmitted without changing value. Okay. So to use the fluid, or this is liquid, you can produce a large force with a small force. For solid, you can produce a large pressure with a small pressure. Okay. And we mentioned that like salt is application of this one. When you use the salt and both sides, okay, the force will be the same. F1 equals to F2. Okay. To have the same force, that means P1 A1 equals to P2 A2. Force equals to pressure multiplied by the area. Okay. So if you have a thought like this, if this is a if this is the cross-sectional area here is A1, this is A2. So you can see if A1 is much greater than A2. If A1 is much greater than A2, to satisfy this equation, P2 has to be much greater than P1, right? Okay. So you can produce a large pressure P2 by a small pressure P1. Okay. When in that case, we need the large pressure to cut through the body. And in this case, we need a large force to lift object. Okay. Any question here?